Good morning. I'm Norbert from the Department of Hematology and Cell Therapy in Paris, Hôpital Saint-Antoine and Sorbonne University. These are my disclosures, and I would like to draw your attention to 2 points. The first one is that this webinar, as well as the previous ones, is done under the umbrella of the International Academy of Clinical Hematology, and you will be able to find it on demand at the address indicated here with the website. And the second point is that this webinar, as the previous 6 one, is supported by an unrestricted educational grant from Air in Space, a French company that you may know, which does material to prevent infection and also pollution. The previous webinars we did were devoted to the study prevention of infection, including, of course, COVID-19. The title of the present webinar is a bit different because it studies the vicious circle of pollution, infections, and exposomes, as well, of course, as preventive measures. It will still concern infection prevention, but it also will focus on the fact that pollution by itself is an independent variable which increases the rate of infection. And this makes sense if you keep in mind that infectious particles are carried on the surface of droplets and also exposomes. The program is shown at this slide. All 3 speakers are famous international experts, and I'm grateful to them for accepting to help us and participate. The 2 first speakers, Jean-Baptiste Renard and Isabella Annesi-Maesano, will address precisely the question of pollution increasing the risk of infection. Our 3rd speaker, Xavier Pollet Villard, will raise a rather new issue, which is the importance of air quality control in other situations, and most importantly, in the in vitro fertilization laboratory. Each one will give a 20 to 25-minute talk, and please do not forget that we meet afterwards to ask questions for the round table. I put on this slide the objectives of this webinar. At the end of it, I guess we will have the confirmation that air pollution has a strong impact on human health, that there is evidence supporting the association between air pollution and respiratory infections, including viral infections, that a succession of high pollution peaks can be more dangerous than permanent exposure to moderate pollution levels, and finally, air quality is one of the component of the embryo culture system that can impact in vitro fertilization outcomes, and therefore comes the concept of IVF clean rooms. This is the slide I usually show to describe the risk of infection during hospitalization in hematology intensive care unit and the Department of Infectious Diseases. All risk factors are indicated here with their relative prognostic weight, but I added for this talk air pollution, which comes up as a very important additional factor. And my 2 last slides are just to show you as examples material that can be used for air purification and control of pollution. These are the plasmare, and the next one is the biocare room with reversible air pressure, positive or negative, according to the need, of course, and the nature of the infection. And of course, these 2 slides were given to me by Air in Space. So finally, last reminder, we listen to the 3 speakers, and please do not forget the Q&A session, which I think may start at 3 p.m. or a little bit later, depending on the speakers. Thank you.
My presentation concerns the relation between pollution, in particular particulate matter pollution, and COVID-19 mortality in Western Europe. we know that a large number or large concentration of solid particles and liquid particles can be present in ambient air. These particles are pollution particles, and we call them particulate matter or PM. And these pollution are mainly coming from anthropogenic activities like traffic, transport, building, heating, and agricultural activity. And sometimes we can find also some solid particles or liquid particles having natural origin. In this case, these particles are coming mainly from volcano eruption or dust, desertic dust transport and of course biomass burning like a major fire. Just to show you an example of the shape of these particles. In fact, we have particles with different size, a large range of size from typically a few nanometers up to tens and even hundreds of micrometers. And depending on the origin of the particle, the shape can be totally different, typically for dust, or some pollution particles. How can we detect such particles? In fact, the reference measurements concern, or normative measurements, concern the mass concentration. I mean, the integrated mass of all particles for below a given size, typically below 10 micrometers. In this case, we speak of PM10, or below 2.5 micrometers. And in this case, we speak of PM2.5. So these measurements are performed by very expensive normative instruments, typically 1 or 2 or 3 instruments per city or per region. But also now there is some private company that develop independent measurements, typically the Pollet company, which provide high resolution accuracy maps of, for example, Paris in this slide, using mobile sensor on the roof of cars. So whatever the source of the data we use, we have always the same regulation. I mean, typically, the mass of PM10 must be below 50 micrograms per meter cube per day, no more than 35-day periods, with typically a mean value of about 40 micrograms per meter. But more interesting now is a recommendation by WHO concerning the PM2.5. In this case, the daily value must be below 15 micrograms per meter cube, with a mean annual value of 5 micrograms per meter cube. The mean annual value is very difficult to reach. It's almost impossible, at least in urban city. But now we are working to reduce strongly the daily value to be below the 15 microgram per meter cube recommendation. It is well known, and the professor, the next presentation by the professor will show the effect of PM pollution on human health. But to synthesize very quickly, we know that this kind of pollution with PM2.5 particles can cause heart attack, stroke, and long-term illness. And particles smaller than that are the most dangerous due to their microscopic size, and they can be found now in all organs of the body. It is well established now that there is a link between air pollution and viral infection. It was well established at least for 2 cases. The first one was for the Spanish influenza in the previous century, and secondly, during the SARS 2002 epidemic also. But for the COVID-19, first study published now 4 years ago, just at the beginning of the pandemic, have shown a possible correlation between pollution, PM pollution levels and COVID-19 mortality. And the study were mainly conducted during the first phase of the pandemic in Italy. We can see on this figure a kind of good correlation. So what is the motivation of the study I will present now? It's to perform, the motivation is to perform an extensive analysis of the possible correlation between PM2.5 pollution level and daily number of deaths attributed to COVID-19 in Western Europe. And I prefer to use mortality data because they are less statistically biased than those considering only the new case of COVID-19. Something very interesting and perhaps strange at the beginning of the pandemic was in the same country a high variability of number of deaths per million inhabitants. We have sometimes a very high level of mortality, typically in the strongly polluted city like Paris, and a low mortality for windy city with low level of pollution, typically like in the west of France. So the best candidate to explain such variability in COVID-19 mortality and some patch of high mortality combined with patch of very low mortality is to consider the spatial and temporal variability of the pollution. We have performed 2 years ago a first study concerning cities and regions in the southern and western Europe to offer a comprehensive representation of the possible link between COVID-19 mortality and PM2.5 pollution. With one really strong constraint, we need to have reliable daily data for the COVID mortality per million inhabitants. And such a reliability of data was not available in all countries. To reduce the dispersion of the data, we have proposed to average the data over 1 week. And for COVID-19, we use data from Johns Hopkins University. And for PM2.5, we use data both from air quality networks and Polytrack data when available. The first study concerned Paris. Paris is a very interesting city because it's a high density population city and a very, very compact city. So when we make a detailed analysis, we can see a very good correlation between COVID-19 mortality at each time the PM2.5 by concentration increase above about 15 micrograms per meter cube. This correlation is counteracted sometimes by the effect of the lockdown. But something also very important is that we observe systematically a drop of mortality when the PM2.5 mass pollution strongly decreases. Similar effect, I mean the correlation between COVID mortality and pollution peaks was observed in Italy and in particular in the highly polluted Lombardy region. On the opposite, all the regions in Europe that exhibit a very low level of pollution show a very low level of COVID-19 mortality per million inhabitants. It is the case, for example, the North Rhine-Westphalian region in Germany. Thus, when we combine all the measurements and when we use different statistical approaches to be sure that what we are done is real, we obtain the same trend. The mortalities always increase and strongly increase, typically by a factor 5 or more, when PM2.5 concentration increase from 5 to about 40 or 45 micrograms per meter cube. But we must consider the various period for the pandemic study. There is 3 different periods. The first one is the initial spread of the pandemic in spring 2020, when little was known about the virus. Then there is another period from mid-2020 to mid-2021. It's a period where the pandemic was better understood and managed. And then there is a post-vaccination period after mid 2021. We see very well in this graph that the trend is always the same. I mean, an increase of number of deaths due to COVID, with increase of PM2.5 mass concentration, but the increase is lower when the vaccines were released than in the first spread of the pandemic. We have performed a more detailed analysis more recently about last year, and in this case, we go far in details concerning 15 cities and regions and country to study with an equal statistically number of cases, low, medium, and high PM2.5 concentration of pollution. And we find something very interesting. We strongly improve the correlation between pollution events and COVID-19 mortality when we integrate the pollution data over a 2-month period. I mean, we need to consider not the peak of pollution at a given time, but the history of the pollution over the 2 previous months. So if we do this, and if we add again a 1-week delay between the 2 curves, we find a very nice correlation between PM2.5 concentration and mortality peaks. And this is true for all the cities we have studied without exception. But in fact, the main factor is not only the level of pollution, but it's the variation of the pollution level. Now we consider the difference of pollution between 2 consecutive weeks, and also the difference between the mortality deaths per million inhabitants. And in this case, we find a really perfect correlation, and we can derive a linear trend. It's really a perfect linear trend between the PM difference or the PM evolution from one week to another and the mortality difference. So it is clear that there is a strong linear link to the duration and the intensity of the pollution. This is an example for other cities or like Paris or for Hungary. And once again, we have this perfect linear correlation. So when we combine all the data, we obtain this kind of graph, of plot, sorry. It is clear that we have always a linear increase of COVID-19 mortality when PM2.5 pollution increase, and this increase is more or less similar. We can show it in a graph, in the plot, sorry, on the left for all the city and the region we have considered, and the mean is the black line. If we consider the difference, it's always the same. We have really a strong increase of mortality when pollution increase, but it's totally a reversible effect. We have a decrease of mortality when the pollution decreases. So it's a linear effect on both sides, increase and decrease of pollution. So the main result and the main conclusion we can derive for such analysis is that first, there is an integration effect. It is clear that a short exposition to a pollution peak is not the main parameter. It is necessary to consider the time exposure on PM2.5 pollution during the previous 2 months. And then we observe systematically a maximum of mortality 1 week after the main pollution. And when we make this statistical approach, we have found that the mortality due to COVID can increase up to 40% for one increase of PM2.5 mass in micrograms per meter cube. But of course, when the pollution decreases, the mortality decreases. Something also very interesting that we found this effect is lower for location with almost a constant pollution level, like London in England, where the pollution is more or less stable, there is no peak, and thus the COVID-19 mortality per million inhabitants was lower than city with a strong pollution peak. So, in conclusion, the inhalation of PM2.5 and, of course, lower particles is an irritant for all the airway, and it favors the penetration of airborne virus and bacteria. So, this study showed that there is the great levels of pollution produce a higher mortality due to COVID-19, and it is clear that we need to conduct such studies not only for COVID-19, but also for other respiratory diseases. Thank you.
Good afternoon. I'm Isabella Annesi-Maesano. I'm a research director at the NIH, French NIH in CERN, and I'm also deputy director of a new institute in Montpellier. I'm a respiratory epidemiology. These are my conflict of interest, all in public institutions where I work to improve public health. So my talk today is about the link between air pollution and respiratory infections. This is the outline of my presentation. First of all, are viruses significantly and not randomly associated with air pollution? And I will show some experimental data and epidemiological data supporting this statement, and then how this can be happen. We know now that there are indirect mechanisms common to both air pollution and viral infection, and directly, because I will show to you that there is one strong hypothesis that was identified as true, that these viruses are in the air. And finally, as a person from public health, I will very shortly discuss why this information is useful. So to start, just some slides on air pollution, that is now a major public health concern, as shown by many journals every week, showing data on air pollution, editorial, etc. And actually, the important statement is that done by Tedros Ghebreyesus, the WHO Director General, is that air pollution is the new tobacco, and we will, epidemics, and we will see why, because I will show that air pollution is a big killer. So air pollution has many sources, and is constituted by many air pollutants, mainly gases and particulate matter, and the sources are both anthropometric and natural. Gases, the best known studied so far are the nitrogen dioxide, sulfur dioxide, ozone, but very, very important, and I will insist on that, are particulate matter and aerosol, a mix of solid and liquid droplets arising from combustion, of which both composition and size are important for our health. And the problem difficult to deal with is that we have to consider that air pollutants are never isolated. They are a complex and ubiquitous mix. And the second fact to be taken into account is that we have no choice. We have to breathe, contrary to what happened in the case of some diet that we can avoid because we simply take out the food that is bad for us. So exposure to air pollution is very huge. This consists of extreme acute events, as shown here, Canadian wildfire this summer, or the away volcanoes, but also this is Paris. Sometimes once or twice per year we have an episode of acute pollution. Another example is the Syrian and Turkish earthquake, in which obviously pollution was high. But what is even more worrying is that we have chronic air pollution events that can be both low or high. Here on the right, you have the map provided by WHO for 2022, showing the exceeding value for pollution, PM, the particulate matter defined, and in some part of the world, but even in our countries. Here on the left, you have a situation in Lebanon, we have industrial towns, or a city, just like Paris in the past. And to show that individually we are very exposed, this is what happened to a volunteer carrying this small device, decanoring, during 1 year. In some cases, in some days, because this is a real-time assessment, this device allowed to show that the person was exposed to more than 300 times the WHO value of 15 micrograms per cubic meter. So coming back to the particulate matter, as we said, the decomposition can be very important, but what is more important is the size, because according to the size, they can go deep in the airways or in the brain through the nose, and once there, they can even go through the alveolar barrier and be at the origin of pathological processes, not only at the level of a respiratory system, but also in other systems, like you can see here, insulin resistance, diabetes, stroke, cardiovascular disease, premature birth, and in general, all causes mortality. This is due to both short-term and long-term exposure, even at low level. And last data, recent data, show that there is also a link with respiratory infection. So since 2021-22, I have started studying the relationship between air pollution and COVID. But before that, I wrote with colleagues a review on the impact of outdoor air pollution on viruses in general. This is what I will report now briefly. So first of all, experimental studies, there are many, I'm just quoting some of the most important that support the link between virus and air pollution in human study, for example, with macrophage taken in the bronchoalveolar lavage that are less efficient to inactivate the influenza virus, or decrease the level of salivary agglutinin, one of the primary antimicrobial proteins. Also in animal studies, there are many studies, but in mice, for example, lower phagocytosis and easier infectiosity induced by pollutants. In vitro study confirm antimicrobial activity that is reduced, and also oxidative stress. All these events are related to exposure to air pollution, and they started already in 1989. You have in our review these more accurate data. In terms of epidemiological studies, evidence started in 2010, but it's sparse, as you can see, with air pollution linked to avian flu, flu alone, bronchiolitis, tuberculosis, measles, and SARS-CoV-1, all viruses that are airborne. So the question, once we knew that SARS-CoV-1 was related to air pollution, was to see whether this was true also for SARS-CoV-2, the virus underlying COVID-19. Just to give you some European and world figures, now we are more than 700 million people that suffer from the disease, 1/3 in Europe, and deaths are almost 7 million. So a big health problem always. The initial epidemiological evidence related to pollution to COVID-19 come from the observation that there were many more cases and deaths in countries or geographical zones that were characterized by air polluted air in excess. So Italy, Iran, and Korea. And when talking about Italy, all the deaths, as shown in this chart, most of the deaths were observed in the Po region, near to Milan, for those that know, where the author Setti et al. Could found SARS-CoV RNA on particular markers in the town of Bergamo, and also they could draw this very simple line showing that there was a relationship between PM10, daily limitable exceedance, and the number of the cases of infection. Since then, there have been many studies. Here, I'm not going in detail, just to show to you that really this has been well studied. Existing study at the ecological level for short-term exposure, and also for long-term exposure, and two are of interest. One at the ecological level, so using aggregated data showing that for 1 microgram per cubic meter increase in fine particle PM 2.5 of diameter were associated with the 8% increase in death by COVID, and this was at the USA entire country level, taking the counties into account. Another similar study was taking into account the world level, and this showed that at the end air pollution contributed to 18% of death to COVID-19. But obviously here we are using data aggregated, as I said, at the ecological level, so we need more precise data. This can be obtained, take into account individual level data. This was done by Italian that showed that in the population of 4 million people, there was a relationship between long-term exposure to air pollution and mortality, and you have here the mortality were almost 124,000 deaths, and this was really related to increase in different pollution. And what is important in this study that they took into account the density of a population, mobility of the individuals, sex, province, GPS, etc., etc. So this is probably the most pertinent study to consider. So how? And as I already said, there are two kinds of mechanisms, those that are related to air pollution related effect and those that are related to an increased risk of exposure to the virus. Let's start by air pollution related effect. First of all, of interest is the fact that because of air pollution, the airways permeability is impaired. Epithelium forms a robust physical chemical barrier protecting the body from environmental aggression, and we know at the experimental level that this is the origin of airways epithelial barrier dysfunction, and the main reason is because of a different susceptibility and exaggerated inflammatory response. More in detail, here you have on the left healthy airways epithelium, and on the right epithelium after the pollution exposure. As you can see, the tight junction that are entire ear open because of the effect of pollution, and as a cascade there is the production of many agents and actors. So disruption of the barrier results in immunological changes, more cells, mucociliary dysfunction by reducing cilia number, global cell metaplasia that are important to defend the organism, and production of inflammatory cytokines that further inflict airway epithelial barrier dysfunction. But there is also another mechanism that is less known. The composition of the microbiome in the airways is characterized in general by bacteroidetes, firmicutes, protobacteria, and after exposure to air pollution, particular matter, this composition change, and this is once again a source of a reduced response to the aggression. So to sum up, air pollution exposure induced functioning of airways ciliated decreased macrophages phagocytosis, decreased immune respiratory defense, and increased, sorry for the arrows, so should be the other way, inflammation. So the second mechanism is about the development aggravation of diseases known as COVID-19 comorbidities, lung disease, cardiovascular disease, kidney disease, neural diseases, metabolic diseases, and cancer. So the main reason, as you know, to enter the virus need a receptor. This receptor is to the angiotensin converting enzyme that is already present in SARS-CoV-1, and this ACE2 as a rule is overexpressed in the case of air pollution, in particular in chronic inflammatory disease, and these diseases are also boosted in some way, aggravated, and develop as a consequence of exposure to chronic air pollution. The second mechanism is increased risk of exposure to SARS-CoV-2 suspending in the air in a polluted zone. I'm really very proud to have signed this letter, which is quite famous. It was difficult to publish it, written by Lydia Moraska, that alerted on the fact that SARS-CoV true was an airborne virus. We appeal to the medical community, etc., to take this aspect into account. Too much time was spent on the fact that this virus could be found because deposited on furniture, etc. But we know now, this has been demonstrating in various ways, that once it is spread via respiratory tract by cough, etc., it stays in the air even several hours. Because of that, there is the contagion. So aerosol is the most important SARS-CoV-2 transmitter indoor overall. And in this context, let's remember that that virus can bound, as shown in this picture, to PM10, that becomes, sorry, a carrier. There are some papers that have underlined this aspect. In another case, for flu, flu was found very far from where it was emitted because of wind, because these particles through the phenomenon of transboundary air pollution can go very far. And the secondary aerosol is that there is a sort of aerosol that is created in the air as a coalescence phenomenon. And so when assessing the aerosol, you can find the virus inside. And this is what has been done in several studies, but probably the most consistent is this one by colleagues from Turkey, Kayalara's first actor, where they assess at the national level the aerosol, and found that it was viable with 23 copies per cubic meters in some way. This means that the virus was active. Obviously, we need to be very cautious in this respect. We need more data. So to finish, why is this information useful? Because we use this information to improve air quality. As I told you, air pollution is a killer, 9 million deaths per year, which is underestimation. And decline air quality is a great risk. Is good for health of people. A larger body of evidence from almost all corners of the world demonstrate that it is possible to improve air quality and human health without compromising economic growth. There are new computations from the European Society showing that you spend, but you earn in life and in bargain. So this context, and I'm really finishing, we need to think larger because air pollution is not an isolated factor. It belongs to what is called the exposome. So in reducing air pollution, obviously we have to act on many others factors, as you can see, indoor pollution, smoking, the urban context, social dimension, and obviously the green spaces, the inequalities, environmental health are very important to be taken into account. And as an indirect demonstration of the fact that air pollution alone is not enough, this study I published in 2022 with other colleagues, we could see that even decreasing air pollution was not enough to see an impact on mortality, and so in relation, in relation with COVID-19. Just to finish on a clinical note, I have continued to work on post-COVID. Here you have our last paper on clinical standard for diagnosis, treatment, and prevention of post-COVID lung disease, because this is a reality. Thank you for your attention.
Many thanks to the organizer for inviting me. I'm going to talk today about the relevance of air quality control in the IVF laboratory. So what happened in IVF is that we came from case reports which took place in the late 90s. Scientists who performed embryo culture procedures shared accounts of decreased cell development after construction of laboratories or remodeling of facilities nearby IVF labs. And also researchers told anecdotes of improved cell development after removal or shelf chemical from the laboratory. So how it all began in the IVF field? Well, the harmful effect of VOCs on embryo development was proven in rodents in 1993 by artificially exposing mouse zygotes to polluted air. So shortly after these findings, a team of embryologists led by Jack Cohen found evidence that when VOCs are present in the lab, they concentrate in big box embryo culture incubator, which is very worrisome as this incubator at that time represented the exact place where embryos were grown in IVF labs. But also they found that there were other sources of VOCs in the incubators. First of all, tissue culture dishes were found to actually release VOCs, especially styrene, toluene, and aldehydes. But also the labels, the affixing labels, or the Sharpie markers that we use to identify dishes also released VOCs. And secondly, compressed gas is a source of VOCs, especially CO2 tanks, as CO2 under its liquid form is a very, very good solvent for chemicals, and it's also used in the industry to actually clean chemical facilities. So it was found afterwards that not changing a CO2 tank before it loses its liquid phase will result in potentially very high VOC release. And finally, new incubators are a source of VOCs coming from gaskets and other incubator components, surfaces. And interestingly, it was found that allowing of period of burn-in before a new incubator is put in use, i.e. setting the incubator at high temperature for a couple of days, will expedite VOC release and improve IVF outcome. So as you can understand, in these 30 years, IVF became a new market for the air filtration industry. And the industry developed filtration technologies, for example, inline gas filters, intra-incubator filters, or mobile and centralized filtration units to improve air quality in the lab, but also in the incubators. And consequently, multiple reports were published in the last three decades, which led to what Norbert calls clinical evidence in the late 2010 decade. However, clinical evidence stems from pre-post studies and hence is posed with a lot of bias. So Norbert did a review of all the studies, the comparative studies, pre-post studies, using different kinds of filtration. And I want to focus on one specific and very interesting study from Munch, because basically all these pre-post studies shown an improvement of outcome after putting in place an air filtration system in the lab or in the incubators. But Munch study is really interesting. So Munch team reported that following accidental removal of carbon filter in the IVF lab air handling unit, a drop in outcomes was observed, followed by an increase of outcome after putting back these same carbon filters. And they also did an excellent job of matching sample size, study duration, and season, and performed subgroup analysis showing that XC cycle were the most affected compared to classical IVF, which may be due to the fact that injected oocytes during ICSI have already undergone a mechanical cellular stressor, which is called denudation, which is not experienced by conventional IVF oocytes. And also because during classical IVF, we don't remove all the cells that are surrounding the oocyte, and all these cells called cumulus complex is actually probably protecting the oocyte from VOCs. So, especially in IVF, pre-post studies are prone to bias because during these decades, we saw an important improvement in incubator performance. We also saw improvement in workflow, in the genetic tested that were used to screen embryos, but also the IVF reactants, culture media, and consumables were improved a lot. The industry introduced many quality control testing, embryo toxicity testing during that time. And also, during that time, a very important change was observed in IVF because we switched from slow freezing embryo cryopreservation to vitrification protocol that are actually way better in terms of outcome. And also, there were also other improvements in the clinical protocols. But more recent studies managed to actually mitigate the risk of bias. For example, in the Heitman study, they used the same practitioner, the same incubator, the same workstation, the same protocol before and after moving from a mobile filtration unit to a centralized filtration unit that was characterized by a better VOC filtering efficiency. So they saw an improvement in practically all outcomes, especially in live birth. Other studies were multicentric with a very high number of patients. This is the case of this study from Palter. So multiple clinics in the US implemented a new air filtration, centralized air filtration unit, which is called Life Air, which was developed in the US. And all these clinics saw improvements in all the IVF outcomes, and especially in the culture outcome, just like the blastulation efficiency, so coming from a zygote to a blastocyst, which is the embryo that we use, and also in clinical outcomes such as reducing the miscarriages rates and having more ongoing pregnancies. But what about particulate control? We talked about chemicals right now, we talked about VOCs, but what about particulate control? So in IVF, this is very difficult to be able to say that particulates have a role. Why? Because there were comparative studies comparing incubators that were using HEPA filters to provide a very clean environment, a class 5 environment, compared to incubators that didn't have this kind of filters. And this comparative study showed that there were no significant differences between the culture and the clinical outcome. But however, there was a small tendency to better outcome when you filter particulate. And also in the IVF field, when we look at culture media contamination, we didn't find any airborne microbial contamination, or at least it was not described. In the study of Gastrop in 2007, he showed that in his lab, contamination of culture media arise from follicular fluid, semen, culture oil, or the most part hands of the embryologist. Contamination frequency is also very low, and contamination frequency seems to be couple dependent. And even if you treat couples with antibiotics, there is a risk of recurrence of culture media contamination even after this antibiotic prophylaxis. So it's probably couple related. And there is no evidence to date of airborne microbial contamination of IVF culture. Another more recent studies from Hong show that actually the frequency of culture media contamination only concerns classical IVF cycles. Well, in classical IVF cycles, the COCs are not removed. I mean, the cells that surround the oocytes are not removed, just like in ICSI. So in Hong studies, they didn't found any contamination during ICSI cycle, only classical IVF. And this contamination were linked to the COC manipulation. And it is interesting because the cumulus oocyte complex is represent actually the higher biomass that we can have in IVF culture. And also, the cumulus oocyte complex has to be manipulated at first without oil overlay. So what they described during in Hong's study is that when you have a high number of cumulus oocyte complex that are retrieved during oocyte pickup, you have a higher risk of contamination because you are doing repetitive manipulation of this higher biomass. And also, during classical IVF, the COCs are cultured overnight, which is not the case in ICSI. So why airborne microbiological infections are so unlikely in IVF embryo transfer? It's because probably we culture under oil. There is a short duration of manipulation. There is a low biomass. The higher biomass is represented by the cumulus oocyte complex. We also use antibiotics in culture media. And also, and it may be the most important thing, is that we are not transplanting cells. We are not injecting cells in the bloodstream. We are only doing an embryo transfer, which is depositing an embryo on the endometrium, which is a mucosae. So the risk is really low. And that's why in the world, when you compare the different IVF lab setting and the different IVF workstation, you find very, very different practices. And also in some countries, just like Australia, the air quality is actually not described in the regulation. There are no requirements in the regulation for air quality in the IVF labs. But still, why particulate control still matters? Well, particulate matters, especially from diesel motors, may contain harmful hydrocarbons, aldehyde, ketones that are absorbed in their soluble organic fraction. And it was discovered in 2018 that actually cultivating maturing oocytes in an environment where they are exposed to this soluble organic fraction actually will disturb mitochondrial localization of these oocytes. It will also destabilize microtubules and lead to chromosomal dispersion. So it seems to be really harmful. So we should have particulate control in the IVF lab. Now we want to talk about what I call the complex interplay between chemical contaminants and the culture system. So chemical contaminants are not always airborne. This is the first notion that you have to understand. Chemical contaminants can partition from the oil to the culture media depending on their affinity. And this has been described in this study from Martinez in 2017, when you use an oil that is contaminated with especially pentanal, which is an aldehyde, or diethylbenzene, which is an aromatic VOC. Well, this component in the oil can be found in the culture media at the end of the culture process. So they contaminate the culture media, and in this study, it was shown that using a bad oil compared to a good oil actually led to a blastocyst formation that was decreased, significantly decreased. This study was not done on human embryos, of course. It was done on ovine embryos. And also, chemical contaminants can be found in the consumable that we use. For example, polystyrene IVF dishes are a direct source of styrene, but not only, also toluene and some aldehyde. And in some instances in IVF, we use polycarbonate consumables that are a direct source of BPA, which is an endocrine disruptor. So we have to think about everything that we are putting in contact with our samples. So another report that is interesting is that oil quality and protein supplementation can mitigate the effect of airborne chemical exposure toxicity. This was described in this study. In this study, the Norbert team exposed mouse zygotes to acrolein, which is an aldehyde, very toxic aldehyde. And it showed that the toxic effect of acrolein was exacerbated if he was using an oil that was of not good quality, an oil that was peroxide, so toxic. And this effect was mitigated by protein addition, which means that the more HSA they put in the culture media, the better the culture and the better the blastulation rate, even though the embryos were exposed to acrolein. Another thing is that the oil overlay can act as a sink for contaminants that are present in the culture media and that are lipophilic. So in this study from Miller, they actually artificially contaminated culture media with bupivacaine, which is a toxin. And by only putting oil overlay and increasing the protein concentration in the media, they were able to mitigate the toxic effect of bupivacaine. And the hypothesis is that this lipophilic toxin was partitioning in the oil, and so the culture media concentration of bupivacaine decreased. And very, very recently, there was a team from the US, Fox team. They did a mass transfer modeling of all the VOCs that have been described in IVF lab. And they showed that the main VOCs of concern that could go from the air to the embryo phase were alcohol, just like isopropanol, ethanol, aldehyde, phenol, and toluene. So it's very interesting for us to have this kind of modelization, because now when we have a report of air quality in a lab, we can actually say if there are very toxic, potentially very toxic contaminants in an IVF lab, and we can choose which kind of filter we can change to decrease this VOC burden in the lab. So what are the mechanisms of gametes and embryo deterioration by VOCs? Well, when we look at acrolein, we can say that having acrolein in the air can lead to radical oxygen species production, microtubule destabilization, mitochondrial dysfunction in oocyte and embryos. So now, how do we prevent air pollution and or improve IVF lab environment? And why did we need a consensus in the field? So my colleagues and I felt that there was a need for an international consensus on the subject of air quality and IVF environment, because regulatory authorities in 2017, 2018 misread the findings on air quality in IVF labs. For example, in Middle East, the authorities try to implement very low relative humidity levels in IVF labs, and which is very bad for the osmolarity of the media. And in Europe, regulators try to force IVF labs to manipulate oocyte and embryos in a Class A environment, which is not needed and also can be harmful as the airflow is really high. And this airflow is actually preventing us to provide good temperature control during manipulation. And in Canada, in some provinces, health inspectors made it mandatory to wash hands and surfaces between each patient with alcohol. And I just demonstrated to you that alcohol is one of the most dangerous contaminants, because it can reach the embryos even if you have oil overlay. So we put in place some recommendation in this consensus that took place in Cairo. The first recommendation are to assess site suitability, then to put in place a dedicated air handling unit for the IVF labs. We have recommendation to clean the air handling unit, the duct surfaces off-site, not in the IVF lab, of course. There are recommendations for to have a fresh air intake that is away from pollution sources, to have a higher level of recirculation in the lab of air circulation, to put VOC filters in place, to have HEPA filters. So many recommendations, positive pressure in the lab, to have a lab that is completely airtight, avoid any plumbing in the lab or the ceiling plenum, and of course to use zero VOC building materials, which is really important to avoid to poison your lab. And also the recommendation about burning in the facility before having culture in place, and also burning incubators. And finally, we ask our personnel to be perfume-free, smoke-free, cosmetic products-free. We use VOC-free cleaning products, which are mostly quaternary ammonium or H2O2. We off-gas all the IVF consumable for at least 24 hours to release the styrene and the toluene. We avoid to have photocopiers and printer in the lab. We prefer laptops or tablets than desktop computers because we can release VOC, especially aldehyde. We respect the maintenance periodicity of the air handling unit, the filter change frequency, and we adapt the VOC filter to the pollution that is found in our lab. So we made several recommendations about the variables, the environmental variables in the lab. And these recommendations are now in multiple international guidelines or national guidelines, good practice guidelines. So now the perspectives. First of all, there is not only the inside lab quality, inside incubators. We know that air quality, air pollution will act on the patient themselves, which will impede, for example, the production of oocyte from the female. It will also decrease semen quality, and also it can impact the embryo implantation. So when we talk about air pollution, we don't talk only of IVF lab air quality, but also indoor and outdoor air quality related to the patient exposure. So this slide is to show you that what we call the exposome of pre-implantation IVF embryo. Air quality is only a part of this exposure. We have also protein qualities. We need also to culture embryos in very low oxygen concentration. So we have many requirements that we try to implement in our lab to reduce the exposure of pre-implantation IVF embryo. And why? Because IVF embryo, so the human pre-implantation of embryo from mature oocyte to blastocyst, during that maturation, a lot of things takes place, and especially some epigenetic reprogramming. So there are waves of demethylation and remethylation, and so there is a risk of epigenetic modification of human IVF embryo in our labs. So the take-home messages. So air quality impact IVF culture and ART outcomes directly or indirectly. There are numerous strategies that have been published to mitigate VOC accumulation in the lab. VOC epuration technology for sure improve ART outcomes, and the exposure of the pre-implantation human embryo is a matter of great concern for clinical embryologists, as it may participate in the developmental origin of health and diseases. So the health of the conceptus is something that we have in mind always. And that's why the IVF field is very prone to eliminate a risk, even if this risk is theoretical or if we have a low quality of clinical evidence. So we use evidence-based medicine, that's for sure, but we often use this metaphor of you don't need an RCT to tell you that if you jump from a plane without a parachute, you're gonna die. So that's exactly how we do things in IVF, at least in the IVF lab. We eliminate any potential risk. So, and the last point is that all cellular culture may be influenced by VOCs, but the effect may be less visible as a higher number of cells are concerned. So this thing is important, and I heard a lot of practitioners in cytogenetics telling me that sometimes when they open a new lab, they have difficulty to culture the leukocyte to have a karyotypes. And so I want to ask you this last question. What about cell therapy labs? Did you experience any drop in results when you had, for example, some building work nearby your facilities? Thank you very much.
Thank you for these talks. Is everybody here with me, the three speakers?
Yes.
Okay, good. So thank you for your talks. I personally enjoyed them very, very much. I received one comment and I have my own question, my major question. The comment is odd, but after all, why not? For instance, Jean-Baptiste Renard and also Isabella and Annesi-Maesano, you beautifully showed that the level of pollution is linked to, let's say, the R0 and the rate of COVID infection. That's okay, that's fine. And you showed many, many slides, many studies. But the comment is, when you are in a lockdown situation, of course, the contamination is going down, everybody's at home, nobody goes outside, and the R0 maybe is not 0, it's 1, I guess. It's very low. At the same time, if the people do not work, which was the case, the air pollution is going down, which you showed also in your slide. So if you study only this situation, and if you forget the reverse situation, how can you say that the decrease in air pollution has contributed to the decrease in the rate of infection? I will start with Jean-Baptiste Renard, if you can answer.
Yes, yes, of course. It's a common question. I mean, in fact, a perfect lockdown does not
exist. Yes.
Not existing. Remember that during the first strict lockdown in France, about 10% of people were working on a large number of jobs to transport, to bring food, and also, of course, medical people in hospital and so on. So you cannot stop the propagation of the virus. And secondly, during the lockdown, some very strong things occur concerning the waste. Everything was burned without a control. And in particular, medical waste, but also all the waste from your normal activities. So if there is an anticyclonic condition, you can increase the concentration of very small particles. So it is what we have observed. Of course, we have observed a significant decrease of the COVID pandemic, of mortality, but not a very so strong decrease because of the activities. And you know, in France, in some cities, young people, student people do not respect the lockdown. It was, in fact, really easy. So we see, of course, a small effect of the lockdown, but not a total effect. Isabella, do you want to add something?
Yeah, it was perfect. I would like to add that agricultural activities also are the origin of the secondary aerosol I showed. So because putting chemicals to protect, to treat the soils, etc., is the origin in some case of an aerosol. And the first lockdown, This was why we had a high level of pollution, in addition to what Jean-Baptiste said. The second comment is that, as I showed, this is really well established. Also, air pollution, chronic air pollution is bad because these are fragilized people that become sick, and those that are suffering from COPD, chronic obstructive pulmonary disease, kidney disease, etc., they are still at higher risk to be contaminated and to suffer. And the graph I show with the different color at the ends show very well what Jean-Baptiste was saying, but in spite of air pollution reduction or not, still we found higher mortality, etc. So because of the exposome that is in the title of this seminar. I mean, the fact that there are not isolated factors, that many things have to be taken into account.
Okay, thank you. I have some construction around me, so whenever you talk, I switch off my microphone so that you don't hear people working around me. Okay.
No problem.
Now you may listen to it. Now I come to my question, and I will start with Xavier, Pollet, Villard, but the question is for the three of you. Suppose you are in an ideal world. Suppose the president of the country calls you around the table. So you are 4 people, and the question which is asked is the following. Pollution is going to be a major medical track for improvement in my presidency. I want to do something. We had cancer, for instance, we had Parkinson's disease. Now we have pollution, right? Okay. So how and what are you advising me to do? For instance, HEPA filters, should I install them in public places? I would say schools, cantinas, all laboratories, all corridors of the hospitals, by the way. Why not? Restaurants? Why not in restaurants? What would you ask me to do? I will start with Xavier, and then I will go to Jean-Baptiste, and again to you, Isabella.
You look as a nice president. I like you.
All right. I switch off my phone not to disturb you, but I listen to you.
Okay, so I will start to talk with the 3 pillars of preventions. If I were to advise you as a president and as a very a good president, I dare say. So I would start with primary prevention. So I would make mandatory that all the building materials should be VOC free or near VOC free, and we have classification, we have organism and standards that would enable us to avoid using bad construction materials, upholsteries, or things like that would release VOCs. So, and other, of course, chemical contaminants. And for secondary prevention and tertiary prevention, I would try to protect the population that are the most sensitive to chemical pollution. So I would start with school, hospital, and maybe also make it mandatory that we have some kind of good ventilation systems in all the building that would host this sensitive population. So
with, of course, I think measurement devices, of course.
Yeah, also.
Okay. Jean-Baptiste?
There is no magic solution. First, of course, we need to reduce the emission of pollutant for my field of research of small particles. Sometimes it can be easy. We know that diesel can produce pollution. We know that wood burning produce a large concentration of very small particles. We can reduce the emission. But also, we need to consider the meteorological condition. When there is anticyclonic condition, the pollution and the polluant stay very close to the sources. When we have a bad weather, as present, the pollution is diluted and we are well below the level of risk. So one solution could be also to reduce all the activities during very strong pollution peak. You know, when there is some snow, we reduce activities. We need to do the same during very strong pollution peak. We need also to adjust the agricultural activities on the meteorological condition to prevent the transport of polluants over a long distance.
So I just would like to ask you a question, and then we go to Isabella and further go. I work in a hospital, of course,
yeah.
And in the department of hematology, everything is protected, and we have HEPA filters and all materials that you can think of to reduce the risk of infection in epileptic patients. But when I enter the hospital and I go through the corridors, there is nothing, absolutely nothing. Would you ask me to make a full protection of the entire hospital, which maybe is not feasible? Would you say that?
Yeah. Yes, of course, you need to protect as much as possible. But once again, we understand that there is some economical constraint, so we need to do our best. But perhaps in this case, a very strong filter for protection could be a solution. It would be the same for the people who take the subway, the metro. For people who have some respiratory problem, these people probably need to wear more or less permanently such mask in case, of course, of high pollution level. When the pollution is low, as in the previous day, it is not necessary.
So we may go back to the underground in a minute, but first, Isabella, what's your opinions on this question?
I obviously agree with what was said by Xavier and Jean-Baptiste. I mean, I'm in public health, so prevention is really important, and also showing that there are some, as I said, Jean-Baptiste, factors that we do not control, climate changes, but only simply meteorological conditions. So I would like to say the same in a different way. I think we need to monitor in real time pollution, indoor, outdoors. We need to make a prediction because of what we know from other fields, meteorological, Meteo France, for example, here in France. And then I would like to go to a very important part, which is education and communication of people. I fully agree with Xavier. We need to protect children, people suffering from comorbidities, elderly, etc. So we need to educate people. This is really even more important for indoor settings because we saw the danger related to VOC, cleaning products, do it yourself, bricolage in French. These are highly polluting situations. So, but really, I think just to say that I really, every time I work, I think also because you are our president, you are full of money, you will put this money in this issue. But unfortunately, the world is large, pollution is a boundary. So we need also to think about those around us. And sometimes very simple things like ventilation, natural ventilation, mask, and in some way also some air purifiers can be important. Just to finish, 3 words, Japan was very good with COVID because of the 3 C's. Avoid the closed space, avoid the crowded space, and close contact settings. And they had only 8,000 deaths for a country which is huge. So no, I mean, only education in that case and culture obviously were enough.
Okay, I'm warned that we have 5 more minutes, and I have a question. The question is very simple, and I have no idea of the answers. What about the nanoparticles? What's that?
I
Somebody?
can start. It's another world. But what do you mean by nanoparticles? Do you mean 1 nanometers, 10 nanometers, 100 nanometers? More or less, we measure. It's expensive, but we can measure particles, solid particles, greater than 10 or 20 nanometers. And we can follow them, and we can study the effect on the bodies. We can detect such particle during pollution events. It's easy. It's not easy, but it's feasible. For really smaller particles, there is some physical problems, some technical problems to detect them. But kept also in mind that in case of pollution, the maximum concentration is between 50 and 100 nanometers. The concentration of particles below 20 nanometers is small. But what's happened at the scale of 1 nanometer, I have not yet the answer.
Okay. Any other comment from the 2 other speakers?
Just to back up what Jean-François was saying, Jean-Baptiste, sorry, we have some data, obviously, but they are 2 parts. But for the ultrafine particles, so 0.01 micrometer, now we have data showing that they are related to mortality, etc. And that is a big issue. Why? Because they are not monitored. It's difficult. I agree with Jean-Baptiste, but not even monitored. There are no recommendation, nothing. So we need another round the WHO to have a guidelines to protect the population against these hazards.
I have just one comment. Don't do sport during strong pollution event. It's really clear. Don't run in a street where there is a lot of cars, a lot of pollution. So no, stay quiet during pollution. It will really, really
Stay quiet. Yes, I mean,
Fully agree.
So just one more comment for Xavier Pollet. I listened to your talk, and you spoke just a little bit of acrolein, and this is something that woke me up because it's related as a catabolite of cyclophosphamide that we are using very much for the conditioning of patients to transplant, and this results sometimes, unfortunately, in hemorrhagic cystitis. So it woke me up as a hematologist when you spoke of acrolein. So listen, time is finished. I want to thank you very much for 3 wonderful talks. This will remain in the bank, in the data bank of the International Academy of Clinical Hematology. It can be accessed on demand, and you can, of course, I guess, use it to the best of your own pleasure. So thank you very much, and bye-bye for today.
Bye-bye.
Thank you.
Thank you very much for invitation. Thank
Yes.
you.
Thank you for invitation. Bye.